Alright, so chapter 7. Out of all the applicants that applied to Xavier in the fall, there's average ACT score, answer the following questions. So, we don't know how large our population sample is, but our sample size is 15. Our true mean is 24 of the population, and our standard deviation is 6, and we're asking what's the probability that our sample size, if we take a sample size of 15, that the sample will have an average ACT score greater than 26. Well, that's what we're looking for. First thing we do is we just click over to our equations sheet and realizing that this is the distribution using X bar, and this is from chapter 6 where we're looking at X. Now we're looking at X bar, so we're going to grab this equation right here. Let's try that again. Alright, good enough. So our X bar is 26. Our mu is 24. Our standard deviation, and this is of the population. Sorry, having a little sore throat problems. All the stress from all the questions I've been getting lately. Anyways, and our sample size, little n, is 15. So, good to go. Now we can figure out what our z statistic is, and we're just performing a transformation to the standard normal, and that's equal to quantity X bar minus mu, and that's divided by, do the quantity again, the standard deviation divided by the square root of n. And there we get our z statistic. So now what's going on is, the probability of our sample mean being greater than 26, that's equal to the probability that a standard normal random variable will be greater than 1.29 rounded. So then we just look up 1.29 in the table. This is the probability that we're interested in. And let me open up our 1.29. So we recall when we looked that up in the table that that's the probability that the standard normal random variable is less than the certain value. In this case, it's 1.29. So this is the probability this is equal to the probability that the standard normal random variable is less than 1.29. And we want the probability that the standard normal random variable is greater than that. So you know, it's as simple as just saying the probability that the standard normal is going to be greater than that value is equal to 1 minus the probability that it will be less than that value. And, you know, again, this is just like the standard normal problems from chapter 6 in this regard, where you should draw out the normal distribution and see what it's looking at, and that can help determine what probabilities, you know, whether you should be taking the 1 minus that value you see in the table or not. So it's going to be equal to 1 minus, and there we get our probability. So that right there is a probability that x bar is going to be greater than 26. And, you know, just by looking at the problem, we can see that that would be less than, you know, the answer should be less than 50%, because we know that the population means 24, and since we're interested in the probability of something being greater than a value that's greater than the population mean, you know, your standard normal curve has the population mean in the center. So this is looking for the probability on the right of like a right tail, and you know that's going to be less than 50%. If you don't follow that, just draw draw it out, and you'll see it. So that's the answer. Not too hard. Let's go down to the next one. Suppose you decide to increase the number of applicants in your sample to 45. Now, what is the probability that the sample average ACT score will be greater than 26? So, exact same problem. The only thing that's different is that our sample size now, instead of being 15, is 45. So, I'm going to put the logic, just copy the logic in there and make sure things are still looking right. Standard deviation still the same. That got updated. My z-score is now 2.236, which is 2.24 rounded. And we're going to look that value up in the table. There's our 2.2. I'll zoom out. 2.24. Right here. And same process as before. We want to take 1 minus the value that we look up in the table. So now we see, you know, the probability of your sample mean being 26 when the sample size increased is less. And that's because as your sample size increases and you're looking at the mean of that sample size, that your sample mean, which is a random variable, is going to become closer and closer to normal. And or you can think of it as your variance. The larger your sample is, the smaller the variance. And so this is the same distance from the true mean, but since our variance is less, the probability of it being that far away decreases. Alright, so last computational problem. If you collect a random sample of n applicants, what's the probability that the sample proportion of students wanting to live on campus will be less than 0.8? Now, P bar represents the sample proportion. Little like italicized P represents the population proportion. Our population size is unknown. We are assuming that P is large. or our sample size is large, so that it follows normal due to the central limit theorem. We're going to go to our equation sheet, and this is the conditions for which your sample size is considered large, but just note that, you know, maybe it'll come up in your next section of statistics, but I'm not going to test you to do this before every probability problem, you know, that has a proportion. Anyways, here's our equation for our z transformation. Beautiful. And let's just make this z statistic. So our p bar is 0.8. Our p little italicized p is 0.85, and so I'll just write numerator, because, you know, numerator and denominator are a little bit more complex in this one. Don't judge me by my spelling. Alright, now let's work on the denominator over here. Our p, we don't want it in red. Sorry, the font's driving me crazy. I'm pasting formats, that way everything's the same. So our denominator is the population proportion times 1 minus the population proportion divided by n, and now you want to take the square root of all of that. There we go. And let's find that z value. Let's move it over here. Numerator divided by denominator. So negative 0.77 rounded. So the probability that p bar is less than 0.8 is equal to the probability that standard normal rounding variable is less than negative 0.77. Put a little comment in there. And the probability, just look that up in our standard normal table. So negative 0.77, 0.77 here, there's one column. That's it.